Hi, everyone. Thank you for joining us for today's webinar, Expect to Inspect, Performing Code Inspections on Your Automation Code with expert Paul Grisafi. I'm super excited that Paul has agreed to speak here today, fresh off his keynote talks at STPCon and Star East. Paul really needs no introduction, but I will give a short one anyway. Paul is a principal automation architect at Magenic. He has created automation platforms and tool frameworks based on proprietary open source and vendor supplied tool chains in diverse product environments such as telecom, stock trading, e-commerce, finance, and healthcare. And if that isn't enough, Paul is also a sought after and very popular keynote speaker. And he's an advisor to software test professionals and STPCon, as well as a member of the Industry Advisory Board of the Advanced Research Center for Software Testing and Quality Assurance at the University of Texas at Dallas. So I think it's best to let him speak now. So take it away, Paul.
Thank you, Adi, and thank you for everyone for joining us today, and thank you to Applitools for giving me the opportunity to speak to everyone today. So after that very nice intro, I'm not going to spend a whole lot of time on the Who Am I slide. Adi did a very good job of letting you know who I am. If you want to contact me, here is my contact info. I will put this up again at the end on the question slide, so you don't have to scribble everything down right this second if you don't want to. So before we get too far down the line, there's something I want to sort of get off my chest and get out there for us that we'll hear a lot about today, and that is automation is software. So if you're developing automation, you're developing software. And it doesn't matter if you're writing code, or if you're writing scripts, or if you're doing record and playback, or you have some sort of drag and drop tool that's building this for you. Somewhere in the stack under the hood, there is software, there's code. And I would even suggest that if you're sequencing thing one to execute after thing two, or vice versa, you've programmed. And we need to treat all of these things that we sequence, all of these things that we create, just like our product software, or at least very similarly to our product software. So what do I mean by that? When we think about our product software, there's certain things that go into it, certain activities, certain tasks, certain responsibilities that we have to deliver this software. So certainly we must plan it. Very seldom as a developer do I just sit down and say, I'm going to press some keys until some code comes out, and then I'm going to have something that works, and I'm going to try to sell that, or I'm going to try to put that into a product or into our automation framework. No, there's planning that happens, and the business side does this for the product, and then the architecture people come in and do it, and the designers and developers and testers, we all get in and we kind of plan, what is this thing going to do? How's it going to work? How's it going to be laid out? How are we going to test it? We need to do the same thing with our automation. Then we have to develop it. We have to test it. We have to treat these things like automation. Again, similar with we need to treat these things like software, and similar with our automation as well. There will be some development activity, the typing of code, the sequencing of events, and then testing. We can't just write some automation and go, cool, now I don't have to do that by hand anymore. No, there's some testing and some validation and building of trust, that we trust as part of the system that we just put together. And we'll have to support it, especially if you're like myself and you live in an automation team or an automation community of practice where we're developing core capabilities and then delivering it to testers and sometimes developers to build automated scripts on top of. Well, sometimes they're going to find bugs in our stuff because, again, it's software. So we have to be prepared and plan for supporting. And we have to store it somewhere. It is generally a bad idea to store your product code on your desktop, because when your desktop crashes, and it will, your disk will crash one day, even if it's at the heat death of the universe, it will eventually crash. You need a recovery plan for that. And it's the same with your automation. So you need to store it somewhere that it is recoverable. And you have to deploy it. You have to get it out to the people that are actually going to use it. And whether that means like myself, where I'm delivering framework and infrastructure and capability to clients or other users. Perhaps it's, oh, I've built some test scripts. Those have to get deployed somewhere to be executed, because in general, it's bad to have your automation records of run on your desktop, because then it makes it difficult for other people to have those automation runs of record as well. And then you start getting into that works on my machine kind of situation. And we may have to version it. We may have to version our automation code, much like we do with our product code. I need to know it's version 1.1, 1.2, 1.3. And sometimes it's even interesting to version our automation code with the same version numbers as our product code in case we have to do some sort of rollback. Hey, we're going to roll back to the previous dot version. Let's run a quick smoke suite, or let's run our regression suite, or some handful of automated scripts to verify that the rollback happened correctly. Well, we'll need to have a match potentially between these two pieces of software, the product code and the automation code. But the one piece of this puzzle, the one piece of the development activities, for lack of a better term, is a code inspection, and that's what we're going to talk about today. So what is a code inspection? It is also frequently called a code review, and you will hear me use the terms back and forth sort of interchangeably, because typically they are. But really, it's a systematic review of code. In the product world, the developers will do a review of the product code to make sure that it meets certain requirements. And in our automation world, my teams tend to do this as well, and I found it quite valuable. Because really, you can think of it as a second or third set of eyes looking at the same code, but potentially coming up with different risks associated with the code, different, hey, did you ever think ofs associated with the code. And generally, what we're doing is we're looking for red flags. Current problems in the code that we can identify, hey, that's a problem, it's not going to work correctly. Or potential problems. Hey, you know what? That's going to be a problem down the line if we cross X number of users per minute or hour, or if our transaction list gets longer than 10,000 or whatever it is. We're going to see performance problems, or we're going to see memory problems, or something along those lines. And I've typically seen these fall into two different types of buckets about how to approach them. Formal inspections, where code is sent out X number of days ahead of time, and then there's a reader and other reviewers, and everybody has to agree, and then there's documentation and artifacts of the review. Typically, you would see this in a highly structured, regulated, or certified environment. We used to do things like this back when I was at Nortel, because we were ISO 9000 whatever certified, so we had to have some of these artifacts and records to keep track of. Or code walkthroughs, and more typically, this is what I've done in some of my later teams, where we're not in such a structured, sort of semi-regulated industry, where it makes sense to say, hey, send me your code and I'll have a quick look at it, and then I'll send you some comments back. And if it's complicated code, maybe a couple of people will have a look at it. Or if it's something that's going to be mission critical to the automation initiative, maybe you'll have more than one person look at it as well. So why do we do code inspections? Part of the reason from way back in the past was compiling and executing in computer time in general was expensive. Sometimes you would have to schedule it at off hours. I know, hard to believe, right? And even today, sometimes we might have to do things like that, not so much for the compile and execute time, but access to the systems under test. Some of us get to work with websites and other things, other applications under test where it's highly available or it's highly shareable, and you tend not to clobber each other very much as long as your data is laid out well. Other resources, other systems under test, like we had back in telecom, were very expensive and hard to share on an individual resource basis. So you had to book time. You had to book time sometimes around the clock. So you wanted to make the most of your development and testing time by getting all of the things that you could address before being out there being out there actually doing work at 3 o'clock in the morning and finding out, oh shoot, I have this problem, I'm gonna have another 2 hours of work and I've wasted all of my time on the product. So first, obviously we're looking for the obvious errors. Your code's not gonna work right, like I said on the previous slide. But also we start looking at the less obvious things like maintenance. Yeah, that works, but that's gonna be hard to maintain. Or you've written some very, very complex code here. Maybe we could simplify it. Maybe we could do some things to make it more maintainable because you're by far the most senior developer on this team. And most of the rest of us are going to struggle with this code. Is there a way that we can make it more approachable for the brunt of the team? Risks, again, kind of like I hinted at on the previous slide. Is there a risk that when we start reaching a higher capacity around performance and around load, where we're going to see some issues, things that we can identify just by looking at the code, knowing that, oh, the insertion on this type of data structure is going to take this long on average, and it's this level of complexity. If we were to switch it, we might have a different level of complexity. Optimizers and code profilers are things that might come into play when we start looking at these types of risks. Classification. Hey, what type of test script is this? Is this something that should go in our smoke suite? Is it something that should go in our regression suite? Is it something that's got a lifespan? It's got a shelf life where we say after release 12 or after featured 1, 2, 3 has been exercised X number of times, we can get rid of that. We can get rid of that, or we can demote it from smoke to regression, or from regression to deep, deep, deep. We only run this type of regression every time we do a major heart transplant on the product. So classifying things it's a good opportunity during code review to work on classification. And cross-training. It is good to have people from different parts of the code reviewing your code, because you will get benefit from things they've seen that you have not, and vice versa. They will get to see this code that they've not seen before, and if they ever have to support it. We often talk about the getting hit by a bus. I've been told that is way too negative, so we talk about winning the lottery. If you win the lottery, and the next day you say, adios suckers, I'm out of here, and they're left to sort out your code, or let's look at it the other way, somebody else says, I'm out of here, I've won the lottery, I'm not coming back, and you have to take on their code, well then you have a much better shot if you've at least gone through the code review aspect of this, or someone else has gone through the code review aspect of this and is at least moderately familiar with what the code is supposed to do and what it's actually doing. So I'm going to remind us of this as we go, but automation is software. And if we're developing automation, we are developing software, and we need to keep it in mind and treat it like we're actually developing software. So how might we approach this? And I don't mean approach developing it as software, I mean approach code reviews for automation. Well, first, we should inspect all of the code, or at least all of the code that we write should be a candidate. And this is one of the places that I found that developing product code versus developing automation code can diverge. In product code, you probably want to review every line of the code, particularly if you are in some sort of life critical systems, or if you have, say, penalties for outages. I've worked with companies where once you're down for a certain amount of people or a certain client for a certain amount of time, you actually got to pay them money back. And that's not a place that most companies want to be. So inspect all appropriate code. There is code when we're doing automation work that I would say it is probably not worth time doing an inspection on that, because we're going to catch any sort of issues at this particular activity that we're doing, or it's low risk, or it's low reward to actually spend the time going through and inspecting. We have to have a plan for stewardship. I used to call this governance, but then I worked with a very talented guy who actually was using the term stewardship. And what he would say is that QA the testers, they're not the owners of quality, they're the stewards of quality. So we in the QA world are tasked with helping ensure quality along, being the shepherd, being the steward, taking care of quality, but not necessarily doing every little bit. Same with your code review process. There needs to be some sort of stewardship in place because there will be contention. When we start getting into development, and this is software development, we're going to start getting into some of the preferences and the art part of software development, where person X is going to think, hey, this is a more elegant way to write this, and person Y is going to think, no, that's the dinosaur way to write it. We should be writing it this other way. We will need a way to break this impasse. And if that's established ahead of time by a steward or a stewardship process to say, here's how we address these types of impasses, these types of conflicts, if that's established ahead of time, then there's going to be less infighting and far fewer of these types of conflicts that tend to linger from review to review to review. Fortunately, there are some software tools that can help take some of the sting out of the cuts of these reviews, and we'll talk about those in a few slides. And involve the team. Now, this seems obvious, but involving the team is a little bit bigger than sometimes what I see with respect to testing and development organizations for a product. A lot of times in the product world, only developers are reviewing the code. Now, whether that's right, whether that's a good practice, an appropriate practice for organization 1 versus organization 2, I can't comment here. Some organizations, the testers are invited in. Testers don't always have the same level of coding acumen. Maybe it's valuable for one organization, maybe it's not. But involving the team from an automation standpoint is highly important. And we'll talk shortly in where the value comes in there. But involving all of the team is very interesting and very critical. And involve the users. Now, this is not something you would do with a product. You would not necessarily invite a user of your website to come in and review your code. Most of your users probably don't have the ability to do that, and you probably don't want to let your secret sauce slip out, right? You don't want your competitors to know what's up. If you have some sort of proprietary algorithm for searching or delivering recommendations and stuff, you probably want to keep that private because that's intellectual property that's valuable to your company. But when we're in the automation realm, especially again, if you live like me, where I'm delivering capability to other teams to actually realize the capability, it's good to involve at least an appropriate subset of those users in my code reviews, even if it's just at the API level, just at the level they're going to see, to comment on that makes sense or that doesn't make sense. That's not going to meet my need or that will meet my need. So consider involving the users here and understand who your user base is. So with involving the team, obviously testers are a part of the team, and with automation, generally they are the primary or at least the initial benefactors of any automation that's created. So when you're looking at this code, remember, you're going to own this. You're going to own this code. All right. So if you've got an automation team, or you've got, or even if you're not, right, you're a fully coalesced and mature and healthy Scrum team where everybody's dogpiling and interchanging on work. Ultimately, what's developed from an automation standpoint is benefits the testing activity. It benefits the whole team, but again, the testers are the primary recipients of this value. You need to be able to understand the code, and maybe not down at the bowels, at the nitty-gritty bottom levels, right? Let's be appropriate with what we can do here and leverage strength to strength. But do I understand what this code is doing? If I look at just the highest level of the script, do I understand it? Because if I don't understand it, I can't trust it. And if you don't trust the automation, you won't run it. Or it'll run and you'll ignore the results and you'll go off and do other stuff on your own. Or you won't understand the results, which is just as bad as not understanding the code and not trusting it, because now you've run it You get these results you can't work with, so you're going to have to go and run those things again. That really, really degrades your value proposition. So you have to be able to understand it, at least at the level of what is it doing and what is it not doing for me. Then, great, I can understand it. Does it work? Does it do what I need it to do so that I can say, I no longer have to perform those activities myself. The technology is going to handle those activities for me. I will go off and then spend my time performing other activities. And can I support it? Again, this may not make a big difference, or this may not be a big deal if you're in a highly gelled Scrum team or Agile delivery team or any kind of delivery team for that matter. But if you are getting things handed to you, if you're a tester and scripts are coming to you because they've been written on your behalf by contractors or consultants, or you have a separate automation team, which is a good idea or it's not, depending on your organization. Eventually, you're going to have to take it over. This team is going to have to take it over. And if you don't think you can support it, there's a miss there, right? Either you're going to need some training, or what's been delivered to you is beyond the level of training you have, and perhaps some changes can be made to that code in order to make it such that it is supportable to you. And these are all the types of things you can find during code review. Even if you're not really highly skilled in coding, you can look at it and understand it or not understand it. You can decide, does it work? Does it do what I need for it to do? Can I trust it? And can I, or at least someone on the team, support this if these contractors, consultants, or this other automation team goes away or they're unavailable? And programmers need to participate in this as well. And I use the term programmers here specifically because I don't want it to necessarily be that developers have to participate. Now, developers know how to code, so they can be very valuable allies when it comes to reviewing code, but they don't have to be the ones that do it. Because when a developer comes in, they need to understand other things about the code. Does it follow coding standards? Are there coding standards on the team? There probably should be some, and we'll talk about standards a little later in the talk. And does it follow those? Are there any performance issues, either now or in the future? Do we anticipate any, kind of like the risks? Hey, this is great, but if you run 20 of these in parallel, you're going to run into these types of performance issues. Do you plan to run any more than 20 in parallel, and work out the questions that way? And are there any coding gotchas? For anyone that's been doing code, writing code, programming, whatever you want to, software development, whatever you want to call it, for any amount of time, we've all been bitten by a thing we didn't know, a thing we forgot, a thing that is in a particular language or on a certain operating system, one of the more esoteric pieces of information that you just have to know. Meaning it's not really esoteric, but it's esoteric from a how you find out about it standpoint. Other developers are great at finding stuff like this, especially if I haven't experienced that particular gotcha before. Hey, that's going to get you if you run it on, hey, that's going to work great on IE. It's not going to work so great on Chrome, or that's going to work great on Windows, but that's going to be performing poorly, or you're going to have this type of issue when you move it over to the Mac. Developers are really good at finding these types of things. So we're in our code review. What do we look for in a code review? So I break this down into two sections. One is called static analysis. And static analysis was where you're looking at the code as code, just as it is. It's not a program at this point. It's not executing. You're not getting log messages and all kinds of stuff out of it. Unit tests aren't at play here. It's just, what does the code look like? And is it adhering to any sort of good practice, appropriate practice your team has put into place? So again, errors are likely errors, coding standards, and comments. So I can actually feel all the hands going up and stuff. I gave this at a local meetup, and there were two guys in the audience that it was like they couldn't wait for me to finish with the slide so they could jump all over me and go, comments are an anti-pattern. If you need a comment, then you absolutely should refactor your code, because code should be self-documenting. And I actually wrote a whole blog post on this, but yes, should. Your code should be self-documenting, but sometimes it's not. Sometimes it doesn't make sense to refactor something to make it readable where a one-line comment or a two-sentence comment would take all of that uncertainty away. And typically it's easy to refactor the code to make it that you understand what it's doing, even how it's doing it. But it's very difficult to refactor code and build in the why, the context around the decisions that were made for this particular implementation. Because somebody new is going to come look at that code. And after about 3 months of not looking at that code, you're new to that code as well. The author is new to that code as well. And I can say that because it's me. I live in this world. I'm a software developer who likes developing software for testers. So I identify with this. And one of the big complaints around comments is, but they're going to get out of sync with the code. That is part of what code review is for. You should be reviewing the comments along with the code. And if you see the comments don't match the code or vice versa, that's an indication that somebody needs to change something. Either the code is wrong, you found a bug, or the comments are wrong, fix the comments so they match the code. And again, big fan of readable code, big fan of code should be self-documenting, but it is hard to document context. If you're going through a list in reverse, that is not the intuitive way to go through a list. It is important to state, why am I going through the list in reverse? And just as important, why am I not going through it the more intuitive way, which is front to back, so that when someone else comes in later, they don't go, well, that's ridiculous. Why would you go through this list backwards? And they inadvertently inject a deficiency into the code that wouldn't have been there if you'd put 2 or 3 sentences that says, hey, here's why we're going through this backward, and here's why we should not go through it forward. And also, this is code, so a compiler needs to read it. It's not going to read like English, but we need to be able to at least read the code and understand what it's doing. So it should be appropriately human readable. And part of what I like to do during code reviews is, especially if I actually have the code, I can where it's not just static, where I'm looking at it on a web page or something, or actually have the project and I can do a compile. I like to look for compiler warnings and other types of warnings generated from the build. Warnings are a smell. Warnings are things that come out of a compiler or builder or linker or whatever particular piece of software you're doing to turn your software into your program into something executable. It's a smell. It says, you know, I'm not going to flag you and I'm not going to stop you from running, but this might cause you a problem. And in some circumstances it might, in some circumstances it might not. It's one of those things where if you never run it on a different machine, maybe it's never a problem. But if you change to the same operating system running on a different architecture, 32-bit to 64-bit and vice versa, works great on Intel, but maybe it doesn't work so good when we port it over and it runs on top of an AMD. Warnings are absolutely smells, and in general, there should be no warnings. But hey, what if a warning is okay? What if a warning is okay and you want that warning to be there because it's integral to what you're doing and you're willing to take on the risk? That's a great place for a comment for that line of code. This line of code will generate a warning for blah, blah, blah. It is okay because here. That way nobody spends time trying to solve that warning, and everyone knows the warning is supposed to be there. So the other aspect of review is dynamic analysis. So like I said, when I have access to the code where I can actually build it, I also like to try and run it because you can get a lot of value here. And testers, this is where you really can bring some value to the table, because if you run it and watch it run, especially if we're talking about some UI tests, it's a little harder with any sort of text-based test or like message-based test for web services or telephony. But if you watch the UI and what's going on there, you can see valuable information that says, yes, this is doing what I expect it to do, increasing your trust. Or, oh, I was expecting that checkbox to be clicked or not be clicked. Let me talk to whoever wrote this code and say, or actually if you're in a meeting for the review, You didn't do a step I was expecting there. Time it. Does it take appreciably longer to run than if you did it yourself? That's not necessarily a bad thing, but it is a thing that you probably should discuss. Does it take significantly less time? Everyone would say, yes, obviously, this is a much better thing. But you might be missing some conditions that way because humans don't work as fast as computers. And it works great if the computer's running through and the automation system's running through and clicking things and checking things that quickly. But if a human does it, then you're going to find other problems simply because humans are slower. And make it fail. What does it look like when it fails? Does it fail? It's looking for a value on a grid, and it's done some computing. So make it so that that value comes back as empty, or it's a different value. Did it fail? Well, if it didn't fail, then there's a problem. If it did fail, it increases your level of trust. Yes, it is at least checking for some of the stuff it looks like it's checking here. And also review the logs and the reports, especially on failure, but on success as well, because these are going to be your breadcrumbs. These are going to be the trails that we will follow to try and figure out, hey, did we found an error, we found a problem when we ran this, right? We found the script reported back a mismatch. Now, is that a product problem or is that an automation problem? Don't know yet. Right now, it's sort of your Schrodinger's cat automation type of situation. So you have to go through the reports and the logs and figure out what happened, what didn't happen, what should have happened. And if you, as the person who is tasked to do that triage and then take action upon the information you found, if you can't understand that information without going to a developer or a giant book of error codes, perhaps that could have been written better. Perhaps that could have been written in a way, those logs, when I say that the logs could have been written in a way such that they are less effort to work with. Fortunately, there are tools out there to help us with some of the code review activities, and most specifically around the activities of coding standards. So coding standards are sort of like editor choice and IDE choice and language choice. Mine's right and yours is wrong. That's the way it almost always works out. So if you can do some things to take the feelings out, like let a computer deal with some of these activities for you, the people that don't like them still won't like them, but there's a lot less hand-wringing and a lot less time wasted with humans going, no, that's in the coding standards, sir. No, ma'am, it is not. You should be like this. The coding standards are wrong and you're misinterpreting. If the computer is doing this for you, then there's a whole lot less dealing with that. So something we use at Magenic is called Style Cop. And what it does is it will go through your C# code and point out violations of the coding standards. So you can configure the coding standards any way you want. And there's some stuff out of the box that it just checks for, quote, good C# code. And you can ignore some and you can add your own in there. This is one we use back at Nortel called Check Style, which does basically the same thing, but it does it for Java. All of the major languages, I did a quick check, all of the major languages have some sort of style checker that you can download and make part of your build process. Because what we do, and what I encourage you to do once your code is up to some level of standard, is to make it part of your build process so that it's great if the code compiles, but if it fails the style check, we're not going to run it. We're not going to deploy it. We're not going to promote it. It counts as a syntax error. It counts as a build failure. So consider putting that into your build process. Linters like lint and flexilint and others, they will find additional errors and additional warnings that your compiler may not flag. It'll find the ones that the compiler flags, but it will find some that it may not flag as well. And a lot of times it's on these sizes of integers and things like that. It'll find depending on which language you have. And some of my experience with lint and linters is many years old, so they may have just been folded into compilers by now. It's one of those things you might go to the developer and say, hey, we're looking at running a linter in our code. We're using C#. Does it make sense to add an additional linter to that? Clockwork does some of these same types of things as well. Resharper is something most of the developers in the .NET world are probably using. It costs, it's not open source, but it apparently will do some of these checks for you, and I also hear it's fabulous at doing refactor work with you as well. And fortunately, I don't have to know them all. You don't have to know them all. There's this URL you can go to here, and the URL will give you a big list of these static analysis tools that you can hunt and pick from. But I have unit tests. I don't need to do code review. So my answer to I have unit tests is so. There are things that your unit tests are not going to catch, and we'll see some examples here in a couple of minutes. But if you do have unit tests, it may eliminate a class of errors that you no longer have to check for in your code. This is a business decision based on risk. Hey, I'm not going to review because I've got unit tests. Okay, that's fine. But realize you're taking on a certain type of risk there. I'll even point out that unit tests are code, so perhaps you should review your unit tests. We do. And there's value there. Not so much around style and around errors, around the code's not going to work, but much more around, yeah, we missed a case here. There's a case that's not covered. But we do pair programming. Good. Pair programming is very valuable in the right situation with the right pair. But do you not need to do a code review? This one's a lot harder to answer. I would say that this one is even more so than the one around unit tests. I would say this one is much more so dependent on the organization and the pair. If you have two brand new people or relatively inexperienced people pairing, because that's just how the pair turned out for one reason or another, doing a code review might be valuable because they won't be exposed to all of the gotchas that some of the senior developers have been. What if you have two senior developers working together? Well, the value of code review brings is going to be different. You're not going to be looking for so many gotchas. You're going to be looking more for these guys are an echo chamber for each other, or these women are an echo chamber for each other. So bringing in someone who's worked in a different part of the code may have different eyes on how different parts of this code is going to interact with the parts of the code that the person you brought in are more familiar with. But this one's a lot less clear cut to me. With unit tests, I still think code review in most cases is valuable, or at least some kind of walkthrough of review or inspection. Here, I really don't know. I would really have to sit down and look at each individual pair and each individual organization before I could form an opinion there. So I suggest you do the same. So I know after hearing all of this, it's still kind of far-fetched, but automation development is software development, so let's treat it as such. And when we come to automation, when we come to code reviews, what we're really looking for are problems, bugs. So I'm going to take us through a few that you might catch in code review. So one is the Boolean assignment. Not every language is susceptible to this. In some languages, this is considered an error. In other languages like C, C#, and Ruby, this will work. It just doesn't necessarily work the way that you would want it to. So we have expected value of 1 and actual value of 2. Obviously, those don't match. Take a second, look at the code, and see what, in this particular case, what the code is going to produce. Okay, so if you said that the code is going to produce the else case, you're not right, unfortunately, because there's a bug in this code, and the bug appears here, where we're using the wrong operator for checking for equivalence. In languages like C, C++, and Ruby, this will work. So what it's going to do is it's going to assign actual value to expected value. So now expected value is not 1 anymore, it's 2, and it returns a non-zero, which is true. So in this case, it will always write to the console if case. It will never ever get to the else case. But I can hear some of you out there saying, but Paul, our unit tests will catch this. Yes, your unit test should catch this because it should exercise both of those paths. But if you forgot one because you didn't code review your unit test, it might not catch it there either. So code review still might provide some value here, but I'm willing to concede this point that unit test is probably going to catch this in the right place to catch this. What about off by one? One of the big problems we have a lot of times in our software. Take a look at this particular code and see what's going to happen. See what you think will happen. So if you think it is going to go through and print out all of the items, then yes and no, because what happens is we have an error in this code. We are checking for the wrong exit condition for this loop. So it's going to go through the 1, the 2, the 3, but then we're going to get some sort of exception, some sort of error, some sort of core dump that says, oh, index is out of range. The last time through we say print my lists of index, there won't be an index 4. There's only up to index 3 because these arrays are zero-based. This is a very rudimentary, easy example to catch, and we might say our unit test would catch. I'll concede that point as well. But this will happen sometimes when we switch languages. In the consultant world, the contracting world, you might switch languages a lot, especially if you know multiple languages, and reacclimating yourself to, wait, now does this return the last index? Does this return the count? Is this zero-based or one-based? Or when you work with Excel interop in .NET, a lot of the Excel work is one-based because that's how the rows are worked, but then the arrays themselves are zero-based. So it can be confusing even to experienced programmers. So stuff we can run into here. Well, this is one I ran into about a month ago. I'm embarrassed about. It took me far too long to figure this one out. And I'll give you a second to have a look and see what this is. This is C#, if that helps you out at all, but I think the same thing will work in Java as well. So the problem I had was the page source was containing page not found, but it did not contain page not found, but it was always printing out that right line every time. I tried all kinds of stuff, and it took me like 20 minutes before I realized, oh, I have a trailing accidental semicolon there. This is what you get when you are trying to write code and listen to someone else's conference presentation. What that says is make the if statement its own complete statement. So the if happens, but it never does anything. And then the code between the braces there, that's just a block of code, a sort of an anonymous block that's doing nothing else other than always printing out that right line. This is something a second set of eyes might have caught after like 1 or 2 minutes had I not been sitting there just beating my head against the keyboard going, what's going on here? How did I miss this? Here's something that your unit tests will not catch, and your format checkers and your coding standard checkers will not catch. And this goes with logs and errors. So what I have here, this is C# code, and I have 3 different asserts on the same values. So the first one looks pretty good. We want to assert that value 1 and value 2 are equal, which they are not. So an assert says if the condition returns true, cool, just keep on going about your business. If the condition is not true, then raise an error, basically halt programming, halt processing, halt execution here. So in this case, what comes out is assert is true failed. Well, that's true. The assert failed, but we're missing all sorts of contextual information here. You're gonna have to go into the code, figure out what this was. Depending on how you have your code set up, what language you're using, you may not be able to figure out what value 1 and value 2 were. So it'd be much better if when we failed in our log, we actually had value 1 and value 2 available to us. The second line here, much more helpful. So the R equal failed, and we expected a 1 but got a 2. Okay, much more helpful. if you have access to the code, because then you can go back and look at, oh, okay, value 1 was a 1 and value 2 was a 2. Not as helpful if you're looking at the results that came out of your continuous integration or your continuous deployment environment, where you're just getting logs. Well, what was 1 and what was 2? Now we have to go to a developer, or we have to go to ourselves. We have to go back to the code and say, here's the problem. What can we do about this? Adding contextual information to make it domain friendly, jargon friendly to those who will be triaging and taking action on these logs, very valuable. So here we get the same information that the assert failed, but we did a little more typing. The developer, whoever typed in this code, did a little more typing for a lot more value, because now it's saying, hey, I expected val 1 to be 1 and val 2 to equal 2. So now we know which variables we were talking about, and if I'd done a really good job naming these, I might know what those two values were: old value, old password, new password, whatever. But then you get this ability to do triaging and take action on logs outside of being inside of the code. And these are the types of things you can catch at code review to say, can I take action on it? Can I support it? Can I use it? Then we have basic software abstraction and encapsulation principles, which is, and you'll hear it as, don't repeat yourself. I have a whole nother thought process around whether duplication is good or bad inherently. That's outside the scope of this. Look for a blog post on that. But here, if our login procedure is to click on the login link, set our email, set our password, and then click the login button, that's great. That's what most sites look like. But hey, I'm a member of USAA, and I don't know, 5 or 6 or 8 years ago, they changed their login flow. They changed your login flow. After you click the login button, now you have to put in a PIN and then click another login button for some sort of double 2-layer security type thing. Wow, if I had 10,000 test scripts and 9,000 of them logged in, that's 9,000 places I have to go and update this. But if I had put this common code into one place, then number one, the code reads a lot better. You're saying log me in. You don't have to look and say, we're doing a good login, a bad login, what's the deal here? And when you have to make changes to that flow, you can make the change in one place, and then all of the scripts inherit that change. Similar, sometimes we just have too much information in our code. It makes it very unapproachable. It makes it very hard to read and understand what this is doing. This is an unreasonable facsimile of some code that I saw not too long ago, and I suggested to the developer, to the automation developer, I said, put that over into its own function. Well, why? I'm only calling it in one spot. I said, I know, but realize who the audience is that we're delivering this to. We're not delivering this to hardcore, strong programmers. We're delivering this to people who are experts at their testing job, and we're going to hand this over to them so that they can do some level of support and execution and maintenance on it. It makes a lot more sense for them to know that we built a database loader and we're loading an XML file to it instead of all these other lines up here. Because if they ever have to go and fool with those other lines, they're either going to find someone on their team that's got the acumen to do it, or they're going to pull in someone else that's got the acumen to do it. And it's far more approachable and less scary to look at this in a test script. Again, things you will find in code review from a support, maintainability, readability standpoint, as opposed to things that are just actually wrong with the code where, sure, your unit tests and your style checkers are going to catch that. And because I haven't beat this in enough yet, automation is software. So let's treat it that way. And one of the ways I said we needed to treat it that way is to plan. So how do we plan for code review? Well, first, most of us are working in some sort of task-based world, whether we're using Trello or TFS or Rally, or pick your choice out there that you're putting your work items into, or maybe it's Microsoft Project if we're doing something more in a waterfall, longer traditional project management route. We're putting work items in there. So put some tasks or work items or whatever your vocabulary is, put them in for the inspection. And I say tasks plural Because if you're going to have 2 people do the inspection, well, then each one should have a task, because each one is going to devote some amount of minutes or hours to reviewing this code. And if we're doing some sort of resource balancing or projection on capacity and stuff, everybody's working on this needs to have an activity so the planning can be closer to what it should be. And to put in a task for rework. We don't do code reviews just to say we did them. Sometimes we're going to find stuff that needs to happen. Some things need to be changed, rewritten, taken out, what have you. Well, let's account for that work as well. And if it's particularly mission critical part of the code or very complex, we might have to do additional retesting and a re-review. So you may want to account for those as well. And we need to remember to be kind. We should be kind all the time. It's like one of the things my wife corrected on our vocabulary early with my 2 boys is we don't tell them to be nice. Anybody can be nice. Be kind, be genuine, be kind, think about others, have some empathy, okay? So software code can be very, very personal and very, very dear to its author. I used to be this way. Back when I first started, I somewhere along the lines became more mercenary and outgrew that. But not everybody makes that switch. Some people really, really look at this as thing that they put their literal blood, sweat, and tears into. And if you tell them they should change something in it, they don't react really well. So understand who you're talking to. Understand what type of person you're interacting with. Is this particular person really protective and caring about their code, or are they a little more like me, mercenary, where code is a means to an end, and it gets us some sort of business value around the line, down the line? Treat those 2 individuals differently. If you're going to send comments where you say, I don't accept this code, consider who you're talking to. I will do like when you're working through TFS with Git, you can say approved, approved with changes, or rejected. I never send a rejected without at least sending an IM ahead of time. And depending on which person it is, I will actually call them, say, hey, let me know when you got a second. And I'll walk them through the things that I think aren't up to snuff, so that they don't just get this cold rejected in their email, and it potentially sends them down the line. And if you're going to reject code, reject it for a good, valid, appropriate business reason. I like reading Noah Sussman's tweet streams a lot. He keeps changing what his actual name is there. Here it says it's the automationist. Now I think he's a door in the stack trace or something like that, but it's always at Noah Sussman. But a lot of times we'll see this in code reviews, and it's, I'll see you in code review. The security of our indentation is at stake. Don't make this about indentation and white space and nits. Make these interactions about adding value to our product so that we're adding value to our client and to our company. So on coding standards, don't get carried away. Don't legislate things that don't need to be legislated. Make sure there's value. There's usually value in some level of standardization, but sometimes we go overboard with our coding standards, and there's no wiggle room in an activity that is largely a social activity. As much as we like to go sit in the corner and type code as developers, developing software is a social activity. It's a cultural activity. You have to work with other people. Certain people have feelings about what's there and what's not there. If you don't have any now, if you're looking to put some in, how about start with what everyone's doing? When we started with our check style in Java at Nortel, what we said was, what does Sun say? This is back when Sun had Java. What does Sun say? What are Sun's coding standards? Well, I'll be here's Sun's coding standards. They're very straightforward. Oh, look, check style has it built in. We're going to go with that. Then there were 2 or 3 other things that we required because they were providing value to us in our C# world, our C++ world. So we added those in as well. And that's what we went with. No muss, no fuss, not a whole lot of hand-wringing and gnashing of teeth over it. But don't do what we at Nortel did, when we built our C++ coding standards. Our C++ coding standards were across 3 or 4 different teams, so we thought it would be best to get buy-in from everybody. So we had a meeting with, no lie, 30 people in it debating coding standards. What we came out with were 4 or 5 standards and a whole bunch of recommendations. And even the standards were weird. The standard for tabbing, and this is one of those holy wars, you shall use spaces. Okay, we have something definitive there. You can't use tabs. Okay, great. And the number of spaces shall be between 2 and 7. That's not a standard. That's a weird choice of indentation that's going to mess up when you go from person to person, file to file, and editor to editor. So don't do that. Don't do that. That was a big waste of time, and we got very little value out of that because we have to focus on value. Remember, the development testing should be in line with the corporate goals, and automation is always in support of those goals because it's always in support of testing and development. So some quick wrap-ups here before we take questions. Some kind of inspection is usually valuable, but do what makes sense. If you're doing pair programming and you're not working on mission critical code, maybe you can skip the review because you're willing to accept the risk that the pair working together is doing the right thing. So let business value drive the inspection. Use tools when you can. Use tools where appropriate. Coding standards and formatting and junk like that, perfect place for tools. It takes some of the ugliness out. But remember, you're dealing with humans. You're giving feedback, just as if I write an article and I work with Sticky Minds and they say, oh, hey, we want you to reword this, reword that. Yeah, they're very good at that, and they deliver that information in a very good way. They're used to dealing with authors. We need to be used to dealing with authors because people that write code, product code or automation code, are authors. So let's make it a positive experience about value for the client and about value for the company. And that's all I have today. I'm willing to take questions now, Adi, if we have time.
Yeah, we're running a bit over, but
I can stay.
so yeah, whoever can stay, that's awesome. I'll just mention 2 things. I'm getting a lot of questions about the recording and the slide deck. So first of all, yes, we did record the session, and an email with the recording and the slide deck will be emailed to you by Monday. Okay, so just know that, and also I wanted to tell you that obviously I'm not going to read out all the compliments that you are sending Paul in the questions panel, but just know that all of them, all your notes to Paul are I'm going to email it to him so he can see it as well. So definitely, if you have anything to tell him, now is the time. And we'll take, I think that we have just a little bit of time, so I see one question here. It doesn't mention the slide number, but it does, I think that it's a little bit in the beginning of your presentation, Paul. And the question goes, are you saying you're judging an application by the way it looks as opposed to how it executes, i.e. the code?
I am judging, personally, I'm judging an application based on the value it brings to the table. Because in general, most of our clients and users and customers, they don't give a crap about software. They don't want software. They want a solution to their problem. And if they have to deal with software to get the solution, then they're willing to do it. It's something that's in our culture now, that software is a valuable tool to have. If we can provide that tool, that software, that application, where it's valuable to us as the deliverers and to the client as the consumers, without doing any level of inspection, okay, I'm in. I'm absolutely in because the value is not there. But in my experience, the way the code is able to be maintained or not maintained, or the way it's quickly able to be debugged or not quickly able to be debugged, weighs directly on the value that both we as the producers and our clients and customers and users as the consumers will value that tool. So that's the position I'll take on that one.
Great. So we are unfortunately out of time. I do want to thank all of you for joining us today for this live session. And of course, I want to thank our amazing speaker, Paul Grisafi. Thank you so much for taking the time to do this. Again, I'm reminding you that a link to the recording and Paul's slide deck will be emailed to you by Monday. And I do hope to see you all at our next event.
All right, thank you very much.